I'm going to turn it over to our next presenter, who is Dave Hyland. Dave is a professor at Xavier University, a veteran presenter at the Analytics Conference, and we're pleased to have him. Dave's going to be talking about using historical data with regression models to help with forecasting. So Dave, take it away.
Great, thanks, Scott. So this is a nice follow-up for the last two. Well, actually, a lot of the ones today. We're going to be using some Llama data. We're going to be doing some graphing. We're going to be doing some R in RStudio. And we're going to be talking about how to interpret some of these things. So like you said, my presentation is forecasting. We're going to use some historical data to predict performance. And like Scott said, I'll give another plug to the, in particular, the third in the series of the SABR certification series has a lot on R, a lot on forecasting. We're gonna dig in and get really kind of dirty with some forecasting here. But just a quick little background on me. I'm a Xavier finance professor, and I personally think that all statistics classes should be taught with baseball data. And I expressed this opinion to the chair of our analytics department one day and found myself teaching a sabermetrics class, a statistics class just with baseball data. And I love it. I think it's a great way to teach statistics, but it's also really fun working with baseball data. In the process, I've also started working with the Xavier baseball team as the director of analytics, and we've started a student organization called the Xavier Baseball Analytics Team, where we try to get students involved with college data and so on. I'm also a very minority owner of the Florence Y'alls, independent minor league baseball team south of Cincinnati here. So let's get into it. So here's our agenda. We're going to use Llama data, and we're going to do some visualizations and regressions. We're going to start with a basic forecast, just to forecast doubles. And then we're going to take a little sideshow and talk about what to forecast. And then we're going to get into some details on forecasting OPS and get a little dirty with the data, try to think about how we do more advanced forecasting and so on. So our first one we're going to look at is forecasting doubles. And, before we jump into that, just think about some of the places you see forecasting done. One of the most popular is Baseball Prospectus PECOTA forecasting. And, they've got the online version. I particularly like the hard copy of Baseball Prospectus. Baseball Prospectus, here's an example here on the left of a page out of Baseball Perspective. As it takes every guy for every team and tries to forecast, gives the historical data, and then for the next season forecasts everything from games to plate appearances and so on. Also, if you get a chance to pick up the paper copy of Baseball Prospectus, the writing is really enjoyable. Some stuff said about every player, but we also see it lots of other places. In the Bill James Handbook, they provide projections. And if we think about projecting for every guy in the MLB, all these different stats, obviously there's going to need to be some, computer work done. We're going to talk about some of the ways you might go about constructing some of these estimates in forecasting models. So, like I said, we're going to use, if you were on earlier, Sean Lahman talked about the Lahman database. That's what we're going to use for all our forecasting here. I didn't realize he was on the conference program, so I've got a link here for last year's. I've seen several of his presentations. The data is fantastic. It's a great place to start doing this. All right, so let's start with our basic forecast. We're going to forecast doubles. And what we want to do, a big picture, we're going to start with the Llama data. and we're going to use our in our studio. We're gonna do some data wrangling to get the data the way we want. We're just going to do a basic forecast. We're going to use last year's doubles to predict this year's doubles. So one of the things that's really helpful in thinking about forecasting is plotting the relationship between your variables. We'll run the regression. We'll talk about how to interpret, and then we'll make a forecast. So before we get into the R coding, R programming, let's just take a look at what doubles this year versus last year looks like. And so on my horizontal axis, I've got last year's doubles and this year's doubles. So we think about this point, Alex Rodriguez in 1995, had somewhere around 6 doubles. The following year, somewhere around 54. So we're plotting this. You notice there's a lot of noise here. Guys go, some year they hit a lot, some years less. We've got some of the extreme identified. But if we plot a line through this, this is our regression line that we're basically going to use to use as our forecast tool. So let's jump into it. I'm gonna go over to our studio, and we're gonna do some programming here. So the packages we're going to use are the tidyverse, which has been talked about, the Lyman database. We'll use performance analytics to do some correlations, ggRepel just to put the points on our graphs, and we'll use the caret package to split our sample into training and test data. All right, so if you've seen some of the Lyman stuff, the nice thing about using the Lyman data in a statistics class or when sharing data with people, I don't have to use any read CSV. I just use this batting. Capital batting is the batting data frame. I can load it into a data frame. I'll call it lowercase batting. Shows up over in my global environment. I can open it up, and I can see in the Lyman database, I've got every guy, player ID for every year since 1871, and their basic hitting statistics. Another way to look at this batting data is use the str, or the structure command. And this will just show me all the different variables in here. And notice I've got X2B and X3B. Those are ones, it'd be more convenient to call those doubles and triples. So as I think about some data wrangling, I'm going to rename X2B to be doubles. I'm going to rename X3B to be triples. And one thing that comes with this data is if a guy plays for multiple teams in a season. For example, Andrew Benintendi played for the Royals and the Yankees in 2002. So he's got 2 lines for 2022. So we're going to group by player and year and summarize everything up. So I've got one line for every player for every year. So this is just some basic data wrangling we're going to do. Look again at our data frame, and we'll see we've renamed X2B and X3B as doubles and triples. The next thing we want to do is calculate, like a lot of good, any good database like the Lyman doesn't have a lot of repetitive things in it, right? So I have hits, I have doubles, triples, and home runs, but I don't have singles. Well, I can calculate that in my programming. It takes up less space in the database when we do that. So I'm going to calculate some new variables that we're going to use: singles, batting average, slugging, plate appearances, OBP, OPS, and WOBA. So those will be new variables. The next thing I want to do from a data wrangling perspective is calculate career stats up to each date. So the cum sum function will take every year and sum up the variable up to that point. So I'll create a new variable called cumulative hits, which will accumulate all the hits up to that point. So we're going to do that. Then we can calculate career OBP, slug, OPS, and so on. So again, a little bit more data wrangling. We're getting closer. One of the things batting has is just player ID, and I'd like to maybe be able to identify some of these players. So the people data frame is the next thing I'm going to look at. So I'm going to load people in, and I notice people gives me a lot of the information about the individual players. For my purposes, I'm just going to be interested in player ID, the birth month, year, and name. So I'm going to use the select command just to get some of those in my people data frame. I'm going to join it with people. And one of the things that MLB does is identifies if a player is born after June 30th, their birth year is the following year. That way we get everybody. If you're born before June 30th, your birth year is normal year. We bump you to the following year. That way we can get ages that are comparable and don't change throughout the season. So we're going to create a new data frame called batting 80. We're going to join with people. We're going to adjust the birth years, calculate age, and create a new data frame called full name. So here we go. We've got batting 80. And the next thing we're going to do, we're going to create some lag variables. All right. So my lag function will allow me to lag OPS, age, career OPS, doubles, and so on. So we're just doing some lag variables there. And here is the ggplot's the function where we can create the graph that I showed in the PowerPoint slide. So ggplot's going to take our data frame. The aesthetic is we want to plot lag doubles on the x-axis, doubles on the y-axis. gmpoint is the command that says I want to make a scatter graph, and then I can put in some labels. Text repel, similar to we were in the Tableau presentation where we put the different names on the graph. GM text repel allows us to do that in R. And then finally, I've got this. I use the high doubles just to plot some of the extreme values. So we'll run those, and we get our graph. Let's see. Well, the graph would look like we showed in the prior thinking. Making to run back and got some problems there, but let's go ahead and run our first model. So here's a regression. We're just going to run a regression. We're going to create a linear model. We're going to explain doubles with lag doubles using the data frame batting 80. So let's run that, and we'll use the summary command to look at our regression. Looks like I've got a little bit of a problem. the code worked well before. Let's just do a little restart and run it again down to this point. There we go. So looks a lot better. So, sometimes like Shauna said in the last presentation, you need to back up and restart. So here's the graph we did. Here is our regression. So this is basically what we're trying to get to. Our regression, basically, here are the results, and we're trying to explain doubles based on last year's doubles with our data frame. So let's look at the key output here. So the regression output gives us an estimate 8.866. So we think about on our graph, that's the y-intercept here. So we're basically saying our forecast, we start with 8.86 plus 0.525 times last year's doubles. So these are our estimates. These are our models that we're going to use for our forecast. The other things that are important to look at in our regression output are our p-values. So our intercept is statistically different from 0. Our relationship with lag doubles, again, statistically significant from 0. The other thing down here that we'll probably look at is the adjusted R-squared. The model explains, or the lag doubles explains, about 27% of the variance in doubles. So we think about, there's a lot of noise. There's a lot of noise. Guys, doubles from last year explain this year's doubles a little bit, but only about 27% of the time. Let's think how we use this for a forecast. So for our forecast, we're going to take the intercept plus 0.525 times last year's doubles. So in 2023, Freddie Freeman had 59 doubles. So if we were to use this simple model to forecast Freddie's doubles for next season, this coming season, it would be 8.886 plus 0.525032 times 59. Okay, we go ahead and run that, and we find our forecast for Freddie Freeman's doubles for next year is about 40. And if we think about what regression is, part of it is regression to the mean. So he had 59 doubles, which is a very high amount for a player. So our expectation for next year would be lower, somewhere around 40. Somebody down below the curve, we're going to expect them to produce higher. Okay. So there's just a very simple forecast for doubles. Let's take a minute and let's do a little bit of a sidetrack and talk about what should we forecast. What should we forecast? So, if I'm baseball prospectus, if I'm providing forecasts for every single thing, yeah, I'm going to forecast doubles. But let's think about big picture. If I really am going to spend a lot of time and I really want to focus on one thing, what should I focus on? Well, one of the things that we think about in studying baseball is that we've got this basic concept that for every 10 runs, every 10 additional runs, or in any 10 additional runs prevented, I should get one more win. And that's not theory. That's just something that we observe over time. So why not one run, one more win? Well, when do I get that run? Well, if I get that run in a tie game, that puts me to extra innings, and I've now got a 50% chance of winning. If I get that one run in a game where I'm losing by a lot, it doesn't matter. If I get that run where I'm winning a lot, it doesn't matter. So if we look at this graph is run differential. So right in the middle, we've got 0. So run differential teams that give up as many runs as they score tend to finish around 500, or they winning percentage 50%. So we look over time, this relationship between run differential and winning percentage. It's a pretty good relationship. In this case, we're just looking at the hitting side of things. So if we just look at winning percentage based on runs scored, looks something like this, right? So here are some teams that we've got some of the outliers plotted. We see there's a relationship. The more runs you score, the higher your winning percentage tends to be. And then if we look further, and this is just a correlation, my top row is runs, and we've got correlations between different batting statistics, team batting statistics. So this is team runs, team batting average. So we look the correlation between team runs scored and batting average is about 59%. So yeah, batting average is pretty good at explaining runs scored. But then we look at slugging percentage, 63% correlation. OBP, 61% correlation. And then the last two we look at are WOBA, which is statistically, a very good measure of run scoring, 67% correlation, and OPS also 67% correlation. So we're going to say that if we're really interested in run scoring for a team, let's look at either WOBA or OPS, because those have the highest correlation with run scoring. So let's go back to our R code, and let's dig in and forecast OPS for players. So you'll notice I've got, I'm going to go ahead and hide all this. All the coding here is to look at that team stuff. We're going to look at OPS, and I'm going to flip back to what we're going to do. So what we want to do with OPS, we want to get more rigorous in how we're going to do our forecast. And to do that, we're going to create training data set and test data set. And we're just going to start with a simple relationship like we did before with doubles. We're just going to look at lag OPS, but we're going to start to bring in other variables like age, the year, et cetera. And we're going to use our test data to decide which model is the best fit. And then we're going to use the best model for our forecast. So if we just do the same thing and we just take prior year OPS to try to predict current year OPS, here's our relationship. We're going to start out with this simple linear regression, and then we're going to start adding variables to do multiple regression. So we look at some of the names on here. It looks like one of the areas is pretty well represented, more than others. But let's go back and let's start coding here. So here is the code to create the plot. So that was the graph we showed in the PowerPoint. Another graph we might want to look at, and again, like I said, it helps to look at the various, it helps to look at the relationships between our variable. Let's look at the relationship between age and OPS. So if we notice, and I'll black out my head here for a minute. We've got a little bit of a relationship between age and OPS. It looks like players, as they get older, they get a little better, but then they just start to decline. So we start to think about relationship between age. We might need to start thinking about some nonlinear relationships. But let's get back and do some more regression analysis. So I've got this little function to calculate some metrics that we can compare regressions with. I don't want to get into, I think that the details on the function are a little beyond the scope of this presentation, but it'll help us. The first thing we're going to do, we're going to create training data and test data. And to do that, we're going to use a seed, the set seed command in R allows us to reproduce our results. When we create this sample, we're going to create a random sample of players. By using the set seed, it'll allow us it'll do the same random sample each time. So it's just going to do a random sample once, and I'll get the same results each time I run the program. If I change the seed, I'd get different training and test data. So what we want to do, we want to take our batting area, the data frame that we created earlier. We want to take the player IDs, and this unique function will, we think about, we've got every player season. It'll allow us to pull all the unique players out of there. So what we want to do is we want to create a training data that's 80% of the players and a test that's 20% of the players. So we're going to create this vector of unique player IDs. Our head command will allow us to look at the first 6 or so. So we see it's going to, our unique players looks like this. We had loaded the caret package earlier. We're going to use train size. We're just going to use our train size. This is just going to be a number to say how big do we want our training to be. The sample function will take our vector of players, and it will pull 2,428 out of that for our training data. So these are our training players, and we'll filter our data set just for the players we've chosen in our training data. And then the players not in trained players will create a test data with. All right, so there's the dirty part. We've got a training set, a test set. Now we're going to get into some forecasting. So just like we did before, where we had doubles based on lag doubles, we're going to use our training data to create a regression to explain OPS with last year's OPS. So let's run the model. We'll summarize it. Let's look at our results and explain. So here are our results. Like I said, we're focused on our intercept. We're going to say 0.339575 plus 0.533731 times last year's OPS. That'll give us our forecast for OPS. We notice both are statistically different from 0. So we think that both the intercept and the lag observation explain OPS. Notice our adjusted R squared, 0.268. So lag OPS explains about 27% of the variability in next year's OPS. So just like we did before, we're going to create test predictions. We're going to use the predict function along with the model we just created, and our test data will create our test predictions. We'll calculate our metrics on each. So notice for our test data, our root mean square error is 0.098. R squared is 0.331. So adjusted R squared for the model and the test data It looks like it does just as well in the test data. So let's use our model. Let's use our forecast. So Dansby Swanson in 2023, his OPS was 0.744. We'll use our intercept 0.339575 plus our 0.533731 times Dansby Swanson's OPS from last year of 0.744. So our forecast for Dansby Swanson for this coming season using this model is 0.736 or 0.737. So our forecast for Dansby Swanson is a little less for 2024 than for 23. Well, so there's the first step. That's basically, we're doing the same thing that we did with doubles. We're using last year's doubles to explain this year's doubles. Here we use last year's OPS to explain this year's OPS. Let's add in career OPS. So instead of just using one variable, we're going to use two variables, both last year's OPS and their career OPS to that point. So let's go ahead and run the model, summarize it. So here are our results. So our intercept, 0.217 plus 0.260 times last year's OPS plus 0.43898 times their career OPS. So we think about it, last year's OPS was important, but their career OPS almost twice as important. We look at our R-squared. Our R-squared is about 27. Now we're up to about 31. So we're explaining more of the variability. We look at the p-values, our intercept, last year's OPS, and their career OPS are all statistically significant in explaining OPS. So there's our model, right? So we're going to run it. We're going to create the test predictions, calculate our metrics. So we're going to do that with our test data. And we see that for our test data, the root mean squared error 0.094, the R-squared is 0.377. We look back to our simple where we just using lag OPS. We see we get a lower root mean square error and a higher R-squared. So this tells me that our model with both last year's OPS and career OPS is better at explaining OPS than just the simple model with lag OPS. So let's add some more. So in this case, I'm going to say, well, okay, I've got some relationships that I think should hold. Now I'm going to think about adding in age. Well, age, we think of maybe as a quadratic, maybe it should go up and then down. So we're going to add in age and age squared. We notice with this I function, this is a transformation function in R that allows us to transform a variable within our regression. So we're going to just do age squared here. So we're going to do our model. We're going to have OPS as explained by last year's OPS, their career OPS prior to this point, their age squared. We're going to do that with the training data. So let's run that and summarize it. So here are results, and we get a little better R squared, but notice really no statistical significance, maybe just a little with age squared. So I would be inclined, this model's not really an improvement. So I'm going to go on and I'm going to try it a different way. And we had several in the last presentation. We talked about analyzing baseball data in R. So age minus 30 and age minus 30 squared we're going to use those instead of just age and age squared here. So let's run our model. summarize it, and notice our results down here. We get statistical significance on age minus 30 and age minus 30 squared, marginally, a little better adjusted to R squared. So we think that model 4 is probably better than model 2. So let's go on. One of the things that we probably think is going on is, we're using data from 1980 to 2022. And, during this period, we have different run scoring environments. So we're going to add another variable in, year ID, as a factor. And what that's essentially going to do is allow each year, we're going to help control for how many runs were scored that year. So let's go and run that. We'll summarize it. And here are results. So notice our adjusted R squared went up to 0.36. So we're explaining more of the variability. The 1981 is our first year. That goes into the intercept. We can see that, based on the year things happened, that, makes an adjustment for the specific year. We see that OPS, lag OPS, career OPS, age, those are all statistically significant, and then a lot of the years. So, we've got a little better model with model 5 than we do any of the others. Let's go ahead and look at our test data. Oops. Let's look at our metrics. We get a little better root mean square error and R squared. Finally, our last model we're going to do, and the idea here is we're going to keep trying things to get more and more explanatory power to explain OPS. So in this one, we're going to add in, we're going to break up, instead of using OPS, lag OPS, we're going to use lag OPP and lag slugging, lag career OBP, and lag career slugging. So we'll run that model, summarize it. Notice probably not a lot of, maybe a little more explanatory power, but most of the variables are statistically significant, with the exception of lag OBP. And we'll go ahead and test with our test data. And our root mean square error is gotten lower than we started, and our R squared for the test data is 0.377. All right, so we've done a lot. We've done a lot. The idea is we're starting with a basic relationship. We're trying new variables, seeing if we get more explanatory power. If we don't get more explanatory power, we go back to the prior model, but we're going to go with that. So we're going to basically say we're going to use this 6 model. We could keep going. We could think about other things, and we'll talk about that in a minute. But let's go ahead and use that to make some predictions for 2000. So the Llaman data goes through 2023. Let's use 2022 players as of 2022 to predict and forecast 2023 and see how we did. So if you notice, we'll go back to original data set. We're not going to use our training and our test data anymore. We're going to use, we're going to call, batting 80 predictions. That's going to be our new data frame. We're going to filter for just 2022 players. We're going to add 1 to their age because they'll be a year older in 2023. And we're going to assume the run scoring environment for 2023 is the same as 2022. So let's do that. And we're going to use, again, our predict function. We're going to create a data frame with the player's name and the predicted OPS. And we're going to put that into a data frame called prediction with names. Then we're going to take our data frame prediction with names and just filter for players. So here we go. So we're going to take our predictions, our 2022 predictions, and we're going to look at Joey Votto. So Joey Votto in 2023 actual OPS was 0.747. If we run our prediction, the model predicted that Joey Votto would have an OPS of 0.799. So his prediction was 0.799. He actually came in at 0.747. So, I'm a Reds fan. We live in Cincinnati. We know that Joey Votto was hurt for a lot of the year, maybe came back a little early. So our prediction comes in a little higher than what he actually did. Let's take a look at Shohei Ohtani. So our prediction for Shohei Ohtani based on as of 2022 was 825. He came in at 1066. So we know he had a pretty good year. Let's look at Kyle Schwarber. Prediction 779, actual 817. Look at Bryce Harper. Prediction 840, actual 900. Look at Bregman. Prediction 772, actual 804, and so on. So one of the things that we find out, almost all of my predictions, most all of the predictions for the model come in a little bit light, with the exception of Votto. Most of these the predictions come in low. Well, in hindsight, what do we know? The run scoring in 2023 was 9.2 runs, almost over a half run higher than the prior year. So not surprisingly that our predictions fall short because the run scoring environment in this era was higher. Now I could have, if I had thought it through, I could have thought at the time, well, the run scoring for 2023 is going to be more similar to another year. So I could have set the year similar to another year that I thought the run scoring might be like. Of course, these types of things are always easier to see with hindsight than at the time. So let's just think about and wrap up some of the what we've done. So, we forecasted OPS for current year based on last year, based on age, based on year. So the purpose of our test data, we want to try to use more variables to get more explanatory power in our regression. The test data helps make sure that we don't overfit the data. Something that works really well with our training data, but doesn't work well with the test data. Let's think about some other things we could use. Look at physical characteristics of players. Lahman only has one observation of height and weight per player. It doesn't measure how they change over time. We could look at practice data. Let's say practice like hit tracks data. We'd expect higher exit velocity players to have higher OPS. We could work in biomechanical data. We could look at minor league data. So the projections we've done are going to work better for players that have been around a long time, not as well for new players. So some of the things that we've done probably wouldn't work very well with a rookie. They don't have any lag OPS. They don't have a career OPS. We need to be cautious for really old or really young players. There are not many in the sample or at all. So, somebody breaks into the MLB at 19 or 20, they tend to be players that do very well. But again, if we had different data, we had minor league data, We had practice type data, those are types of things we might work into our regression. One of the things that I might want to do is use pooled regressions, use a PLM package instead of linear model. Give me some, it would fix some of the independence issues in the data, but probably give very similar results. Need to think about the run environment changing. Probably should have thought more about the new run rules in 2023. As I think of, forecasting 2024, will that be the same type of run scoring environment as 2023 or very different? It's also not going to be very good at forecasting, if a player gets injured and so on. So we think about some of the resources out there. The SABR Analytics certification course goes into R a lot. Especially the third course. He also talks about forecasting. I'd strongly encourage a lot of people to look at analyzing baseball data with R. Let's take some questions. So Abby asks, what metrics or measures do you prefer when checking the explanatory power of the model? I tend to like R squared a lot, but probably more common. Most people look at root mean square error. So that's probably type of measure people use when they do this. Oh, so the question is, the Xavier team is now in season. What is your focus in helping the team? Probably a lot of our focus right now is on advanced scouting, trying to put together kind of templates for the coaches that has a lot of the basic statistics in there. So as they go in and look at film, they can fill in the template that already has the basic statistics and so on of the player. So we do a couple advanced hitter reports, and we also do a pitch arsenal report. Prior to those, we use 643 charts, Synergy, and this is our first year with TrackMan. So there's definitely a lot of really good data in TrackMan, and we're seeing more and more college teams getting TrackMan. Obviously most of the SEC, the bigger type schools already have had that for a while. We're seeing this is our first year with TrackMan, and we're seeing more and more Big East teams even getting TrackMan. So there's a lot of data in TrackMan to use as well. So the question, the function, I assume linear versus quadratic versus something else seems very important. Is trial and error still a good way to do this? Probably that's the way I've looked at it. I think as we plot data, I probably should have created a graph of run scoring by year. That would have helped me understand the relationship on runs across years. We saw with age, there's some a quadratic shape, but I really think the more that you graph data, the better you can understand the data you have and think about whether you need to use nonlinear relationships as well. So I think that's a really good question. Let's see, if I were to continue enhancing the model, what would your next be in addressing the increase of runs per game? Again, that's the subjectivity of it, right? If I were to, think about using the forecast for 2024, I would want to, we stopped at 2022 because that's where the Laman data ends. But if I had 2023, I would obviously want to use that for 2024. So trying to think about whether the run scoring really in 2024 was going to be similar to 2023 would really be, that would be the decision I would be trying to come up with. what to use as sort of that dummy variable to explain the run scoring environment. Would I consider adding home par factors? I think definitely, especially as you think about a player changing teams, right? So if a player is changing teams, so they're going to go from one park to another, having some kind of adjustment to your forecast that would account for their new home. I don't think you need to worry about it for players that are going to be playing on the same team. We would expect the statistics that are or the part that's baked into their OPS is already in there. But if a player is changing team, adjusting for a park factor would be pretty important. And maybe a better question would be, rather than using OPS as a raw number, using a park adjusted OPS, that OPS plus would be a better thing to forecast than OPS. Let's see, how can we integrate advanced regression models into existing analytics? Let's see, I'm gonna skip that one. I don't know quite how to answer. So here's a good question. How did you get buy-in from your coaching staff and your analytics and reports? Do you go with them? Do you go to them with ideas typically, or the other way around? I think Trevor, that is a really good question. If you're going to work with a team, if you're going to try to I think the most important thing is that, for me, it's been to kind of slow play, try to be responsive to what the coaching staff wants and not push too many of my ideas, but also just putting things in front of them. Hey, I did this report. Do you find any use for it? I think the sabermetrics community sometimes gets a bad rap for, being too dogmatic about, never bunt, never, steal. I think if you're going to work with a team, you have to kind of show that you can be useful. Try to do things that are going to help the coach, but also show them things and say, hey, can you get any use out of this? What could you do there? I think not being too pushy, trying to listen and trying to be useful. I've had students that come in and some of them are really responsive. They pay attention and they go home and they work on the things the coach is looking for. And then others that are kind of get in the way a lot and are not as helpful. So I think trying to be sensitive to that situation, I think that's a really good question, because I think there are a lot of both we've got a local high school that is doing a lot trying to help their staff, and there's a lot of opportunities for students to do and get involved with stuff like that, and just being sensitive and trying to be useful. And sometimes that might be running the scoreboard or doing things well that are useful, and not being too distractive and asking too many questions in the dugout. How do I think AI will affect the projection process? What portions will it streamline the most? I don't know the answer to that, but I have noticed that once I've gotten to a point where I've done a lot of, I've only really started working with R in the last 5 or 6 years. And, I had a statistics background before, but learning R has been new. And one of the things that I found very useful for AI or just ChatGPT is, hey, here's my code. I'm getting this error. It doesn't work. Using ChatGPT to find error. I think AI is really good at finding, hey, you're missing a parenthesis here. Your code isn't working there. I think you have to be really careful if you don't know what you're asking, I think you can get a lot of really misguided types of responses from the like ChatGPT. But if you know what you're asking and you're paying attention, it can be useful, but it also can get you some loops where it'll fix something, but it'll break something else. I think you have to get to a point where you've got a pretty good understanding of what you're trying to do before you start to use the AI. But I don't know about big picture. I think as a useful tool for programming, I think that part of AI is useful. Hector asked, what are the latest advancements in regression modeling techniques that could be particularly beneficial for baseball analytics? Shauna kind of touched on this a little bit. A lot of the machine learning type things, they're really just advanced regression, but it helps put things in different buckets. Like, one of the things that I find very interesting is this metric of like stuff, where we take all the characteristics of a pitch, like velocity, movement, and so on, and put it in machine learning to try to predict how effective a pitch is going to be and how effective it is relative to other pitches. So I think some of the machine learning techniques are fun to use, and they're being used a lot in things like stuff models to try to tell how useful a pitcher's arsenal is and compare guys, based on the pitches they throw. To use any predictive models for evaluating potential recruits. Not so much at the college level. I think if you think about looking at potential recruits, I think probably college coaches are more interested in some basic stuff like how hard do they hit the ball, how hard do they throw, what's their projectability. You're looking at boys and trying to figure out what they're going to be like as men, I think, or young men, college age. So I don't know. I think it's really tough to use any kind of data on high school players. It's so random. What to hit, what's in the air, what kind of conference is a kid playing in. I think that's a tough one. A couple more questions here. Alexander asks if there are non-regression techniques that work well for regressions. I'm sure there are. I know more about regression, so I use that. I think that probably wraps it up, Scott.
Hey, Dave. Thanks.
Yeah. Thank you.
Great stuff, man. I appreciate you being here again. Best of luck to the baseball team. How are you guys looking? What's the prognosis in the Big East this year?
Well, we're picked second behind UConn, but we beat them in the tournament last year. So we're also hoping we do enough preseason that we can be a two bid conference. So we'll see. We're off to a pretty good start. We play LSU this weekend.
Well, best of luck. Keep in touch. I'm sure Dave would love to connect with y'all if you have questions or emails. Like I said, all of our presenters are extremely accessible and great when it comes to connecting with our attendees. So thank you so much for being here, Dave. Again, we appreciate it.